truth tables for negation, conjunction, and disjunction. All right, so in this lesson, we will be using truth tables to determine when a compound statement is true or false. In this lesson, we will be using different kinds of truth tables. So by the end of the next few lessons, we'll have 5 different truth tables. So let's get into the first one. All right, the first truth table is for negation, and it's pretty simple. If P is a true statement, that's what case number 1 says. If P is a true statement, then the negation of P, or not P, would be a false statement. If P, this is case 2, if P is a false statement, then the negation thereof, not P, would be a true statement. The next truth table is for a conjunction. Don't forget that a conjunction is a compound statement. A compound statement, which means it consists of 2 simple statements. One of them is called P, and the other statement is called Q. Now, there are 4 possible ways this can occur, all right? So, statement P can be true, and statement Q can be true. So, both statements are true. Statement P can be true while Q is false. Statement P can be false while Q is true, and then they both can be false. For example, let's say we have this compound statement. The carpet will be delivered on Thursday, and the furniture will be delivered on Friday. So let's say you're redecorating a house or something like that, and you purchase a carpet and you purchase furniture, okay? You explain to the salesperson, the carpet has to be delivered before the furniture. The carpet has to be delivered before the furniture. And this is what the salesperson says. The carpet will be delivered on Thursday, and, so there's your conjunction, and the furniture will be delivered on Friday. There are 4 different outcomes. And this table kind of illustrates the 4 different outcomes. So for case 1, of course, this would be considered P, everybody. The carpet will be delivered on Thursday. That's statement P. And then statement Q is the furniture will be delivered on Friday. So for case 1, true, true, that means the carpet was delivered on Thursday and the furniture was delivered on Friday. So the salesperson kept their promise. Now, case number 2 is, well, the carpet was delivered on Thursday, but the furniture was not delivered on Friday. That could happen, right? Therefore, the compound statement we're going to say is false. We're going to notate that in a new table in just a minute. In other words, in order for a compound statement to be true, both P and Q have to be true. In other words, in case 2, just because the carpet was delivered on Thursday doesn't necessarily mean the salesperson kept their promise. In order for the salesperson to keep their promise, the carpet has to be delivered on Thursday and the furniture has to be delivered on Friday. So case number 2, we're going to say in just a minute, we're going to notate this, that the compound statement, this compound statement, folks, I'm going to write it down in just a minute, P and Q. This compound statement, we're going to say this is false under case 2. All right. Case 3, false, true. In this case, the carpet was not delivered on Thursday and the furniture was delivered on Friday. Now, if the carpet is not delivered on Thursday, as promised, then the entire compound statement, P and Q, is false, right? The promise was not kept. Finally, case 4 is when neither of these 2 things happen. Neither the carpet was delivered on Thursday, nor was the furniture delivered on Friday. So in this case, the salesperson really did not keep his promise, right? So then it's only in case one where the salesperson kept their promise. It's only in case one when you have true, true, that the compound statement is true. All other cases, the compound statement is false. So I want to illustrate this. I want to edit our table right here for conjunction. So I'm going to get this out of the way, this writing here, and I want to expand our table. So follow me in your notes. All right, here we go. So here's our table for a conjunction. Notice that it's only in case one where the compound statement P and Q is true. So the only way a compound statement like this is true is if both P and Q are true. All other cases, if at least one of them is false, then the compound statement is false. All right, so this is our truth table for a conjunction. All right, I think this is worth adding to your notes. The conjunction P and Q is true only when both P and Q are true. All right, this is going to be different than a disjunction. Let's get into that now. Now, here's our truth table for a disjunction. Remember that a disjunction is a compound statement, right? So you have two statements, P and Q, but this is our symbol for a disjunction, and it's interpreted or read as or, P or Q. Now, notice that in every single case, P or Q, the disjunction, is true in every single case except case 4. Let me give us an example so that we can, better understand these outcomes. Let's say you see this job ad for a civil technician, and the ad reads like this: Municipal Program for Redevelopment seeks an on-site technician. And these are the requirements, okay? The applicant must have a 2-year college degree in civil technology or 5 years of related experience. Okay, so if somebody has the 2-year college degree, that means P is true. If they also have 5 years of related experience, that means Q is true. And if P and Q are true, then that person for sure qualifies for this position because they have both a 2-year degree and they also have 5 years of experience. That person, just because they satisfy both requirements, would not be disqualified. They would be qualified for this position. So if P and Q are true, then the disjunction is true. So that's case 1. I think case 2 and case 3 are pretty straightforward. In case 2, P is true, but Q is false. In other words, the applicant does have a 2-year degree, but does not have 5 years experience. But that's okay because it says the word or, right? So as long as one of these conditions are met, then you qualify. So in this case number 2, the disjunction is true. In case 3, it's false and then true. In other words, this person maybe does not have a 2-year degree, but they do have 5 years experience. They qualify. So the disjunction is true. Case 4 is the only case that gives you a false outcome for a disjunction. So the disjunction would be a false statement if a person has neither a 2-year degree nor 5 years experience. That would be the only case in which you do not qualify. So I hope this little example here helps explain or helps us understand these truth values for a disjunction P or Q. Again, I think this statement is really valuable for our notes. The disjunction P or Q is true when either P is true, Q is true, or both are true. In other words, this disjunction is false only when P and Q are false. You can write that. You can add that to your notes if that's helpful. P or Q, the disjunction, is false only when both P and Q are false. All right, folks, we've made it to our first example, and the first time we're going to construct a truth table for a statement. All right, so we have a conjunction. All right, so this is the conjunction symbol, right? So, and the way we read this is P and not Q. Now, we've talked about how a conjunction is only true when both statements are true. All right, so let's build or construct this truth table. All right, here we go. Okay, so we're going to learn very quickly here that when constructing these truth tables, we need to be super organized, super neat with our rows and columns, because these are going to get really, 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 I mean, there's a lot going on. And so please notice that first, in my first column here is all of my possible outcomes for P, and then all of my possible outcomes for Q. All right. And then over here, I'm actually going to put like a little, separate this like that. Over here is actually the statement that was given to me, but I spread it out because we're going to have truth values underneath each item. So I'm going to have 4 different columns here. And what I want to emphasize is this is going to be my answer column right here. This is my answer column. I want to know when this conjunction, when this conjunction is true. And so this is my answer column. All right, so the first thing I'm going to do is my first column is P, right? That's what the statement is. So basically, it's as simple as this. Copy and paste all of your P values here in this column. So let me just do this. True, true, false, false. Okay, I'm skipping over my answer column. I cannot fill this in until the very end. I'm going to jump now over to Q. I'm going to copy and paste all of my Q values underneath the Q column. So true, we have false, we have true, and we have false. I'm trying my best to make sure this all lines up, right? The rows look really neat. All right. Now, in order to fill in this column, which is the negation, this negation is not Q. So remember, if Q is true, then the negation thereof would be false. If Q is false, then the negation thereof will be true. So here we go. In this first row here, Q is true, therefore the negation is false. In the second row, Q is false, therefore the negation is true. In the third row, Q is true, therefore the negation is false. And then finally, Q is false here. That means the negation thereof will be true. All right, now I'm ready to fill in my answer column. But keep in mind that in order to fill in the answer column, these are the 2 columns that I'm looking at, that I'm referencing. P and not Q. Now remember, in order for the conjunction to get a true truth value, both of these statements here, both of these columns here must be true. All right, so let's go for it. P is true, but not Q is false. That means the conjunction is false. In row 2, P is true and not Q is true. Therefore, the conjunction is true. All right. And then we have false, false. That means that's false. And then we have false, true. That means the conjunction is false. So the only time this statement, P and not Q, is a true statement is when P is true and Q is false. That will give you a true outcome. That will make this whole statement true, is when P, that statement is true, and Q, that statement is a false statement. Once we do this more and more and more, we're going to be able to find like shortcuts or ways to kind of make this more concise. Like, for example, even in this example that we came from here, I didn't necessarily need 2 different columns for this. I didn't need a separate column for the negation and then for Q. I mean, Q is right here, so I can consolidate these 2 columns. I mean, if Q is true, then not Q would be false. If Q is false, then not Q would be true. So I don't necessarily need this column here. So there's ways to consolidate this, and we'll do that in the future. All right, we have a new statement here, and it is the negation of not Q or P. All right, let's go for it. Let's start with our P and Q statements. All right. I have my P column and my Q column, and to the right of this vertical line that I've drawn here, I'm going to put all of this. Now, I'm going to copy all of this down, but kind of space it out, all right? So the first thing I'm going to write is the negation. That's going to be my answer column. I'm going to highlight that now. Okay. All right, that's my answer column. And then I'm going to have a column for not Q. Not Q. See, I'm not going to separate that and make a separate column for not and then another column for Q. I'll just take not Q together. And then I'll have a column for or, the disjunction. And then finally, a column for P. All right, so the first thing that I think I'll do here is answer this, fill in this column here, and then I'll jump over to P. That should be easy because just copy and paste your P values from before, right, here. And not Q should not be too hard either, because if Q is true, then not Q would be false. Let me fill that in. I'm just going to do the opposite of what I have written earlier for Q. If Q is false, then not Q is true. If Q is true, then not Q is false. Let's try to be neat. And then if Q is false, then not Q is true. All right. Now I'm going to jump over to my P column, and here I don't really have to think. I can just copy and paste my original P values. So I got true, true, false, false. Now, for this middle column here, this is or, right? Remember, for a disjunction to be true, just one of these two statements has to be true. Either not Q has to be true or P has to be true. They don't have to both be true, although that's cool as well. At least one of them has to be true. All right, so in this first row here, P is Q, P is true and not Q is false. So since P is true, I can say the disjunction is true. Okay, in the next row, they're both true, so this is absolutely true. In the next row, they're both false, which is not cool, so this is going to have to be false here. And in the last row, not Q is true, and that's good enough to make the disjunction true. All right, so now all I have to do is negate the disjunction. So if the disjunction is true, the negation thereof is false. If the disjunction is true, the negation thereof is false. If the disjunction is false, the negation thereof is true. And then finally, if the disjunction is true, the negation thereof is, if I can squeeze it in here, false. So the only time we get a true statement for our negation is here, and this happens, this outcome occurs when P, the statement P is false, and the statement Q is true. That's what's going to give us this favorable outcome of a true value for this entire statement, when P is false and Q is true. All right, folks, this one's going to be a lot of fun. We're going to have 3 different statements here. All right, so this truth table is going to be pretty wild, all right? It's going to be bigger than all the others because we have 3 different statements. All right, so this is the statement that they want us to explore. Santana is home, that's P, and he is not at his desk. So that's going to be, okay, so whenever we use P, Q, and R, we choose P, Q, and R to represent statements that are not negated. So to say that he is not at his desk, that's a negation. So I'm going to let Q represent Santana is at his desk. So then this is going to be not Q. He is not at his desk. Or he is sleeping. So that's statement R. All right. So therefore, the statement that we're really exploring is P, Santana is home, and not Q, right? He is not sleeping. Notice the comma. That's going to put these in parentheses. Or, so this is a disjunction. He is sleeping. So, or R. All right, now listen. Because the disjunction is the outermost symbol, that means this entire statement is considered a disjunction. Therefore, when we construct our truth table, the answer column will be underneath the disjunction. All right, folks, here we go. Now, as you can tell, we have more cases than 4, right? We actually have 8 cases to represent all of the different outcomes, right? All right, so here we go. So this could happen. In case 1, P could be true, Q could be true, R could be true. All 3 could be true statements. All right, so the first thing I'm going to do to help me not get confused here, I'm going to keep the first 2 statements true, and I'm just going to negate this one, all right? So true, true, false, that can happen, okay? Now what I'm going to do is I'm going to go back to the first case here, but now I'm going to make, instead of making R false, I'm going to make Q false. So this could happen true, false, and then true. And then what else can happen is that both of these statements, Q and R, can be true. So I'm basically exhausting all of the options where true is P. P is true, but then like what happens if P is true every single time, but then Q and R kind of change from being true or false, all right? Now, what I'm going to do is I'm going to make P false for the first time. Actually, the last 4 cases will be when P is false, because I've already exhausted all of the different scenarios when P is true. The last 4 scenarios will be when P is false. Now, in case number 5 here, P can be true, P can be false, but Q and R can be true, right? In case 6, P can be false, while Q is true, but R is false. In case 7, P is false, Q is false, but R is true. And then last, this also can happen. All 3 statements are false. So this exhausts all of the different scenarios. All right, now here we go. On the right side is what I will use our statement that they've given us. So basically, if I can just scroll, it's this statement here. Okay, P and not Q, and then or R. All right, so let me write this down. So we have parentheses. P is a column, okay, and is a column. Not Q is a column. Close that parenthesis there. Or is our answer column, and then we have R. All right, so this is definitely our answer column. I want to highlight it. Okay, that'll be our answer. All right, some of these columns are pretty easy to fill in. Like P is easy to fill in because I'm just copying and pasting all of my P values. Let me move this entire screen up. There we go. So let me do that. Let me fill in all of my P values. So I have 4 trues and then 4 false. All right, so true, 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 true. I'm just copying that first column. False, 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 false. Okay. The next thing I'll do is I'll fill in not Q. So not Q can be you can get not Q by just looking at Q, right? And negating all of these truth values. So if Q is true, then not Q is false. If Q is false, then not Q is true. So let's go for it. Not Q here would be false, and then false, true, and make sure things line up, okay? Make sure you're really neat here. I'll try to do the same. false, false, true, and true. All right, very good. I just negated all of my Q values. And you want things to line up. All right, now this is a conjunction. And remember that the only way a conjunction is true is if both values are true. The only time both values are true are, here we go, row 3 and row 4, case 3 and case 4. Yep, that's it. All the other ones will get false. So let me see if I can fill that in. So the conjunction's false, false, true, true, but then the conjunction's false, 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 and false. Okay, because again, in order for a conjunction to be true, both statements have to be true. Now, we can just copy and paste our R values. All of our R values, just copy them over. Let me do that really quickly, carefully. True, false, true, false. Let me try to be neat. True, false, true, false. All right, so true, false, true, and then false. All right, now we're ready to fill in the disjunction column. All right, and the two columns that we're comparing are, of course, column for R, and this column here that I can't grab. Hold on, let me move this down a little bit. There. So you're looking at these two columns, and I can highlight them for us if it visually if it helps. You're looking at those two columns there, okay, to fill in your answer column. Remember though, your answer column is a disjunction. The only way a disjunction is true is if one of them are true. You just need one of them to be true, or both, right? So here we go. For case 1, R is true, the conjunction is false, so the disjunction is true. For case 2, they're both false, so this is false. In case 3, they're both true, so the disjunction is true. In case 4, the conjunction is true while R is false, so the disjunction is true. I'm trying to keep my vocabulary right here. And then for case 5, my conjunction is false while R is true, so that this is true. And then case 6, we have false, false, so that's false. In case 7, we have false, true, so it's true. In case 8 is false, false, so then this last one is false. It's kind of outside of that little box there. But all right, so then we have how many true outcomes? Case 1, case 3 and 4, and 5, 3, 4, and 5, and then case number 7. All right, we have a follow-up question. Suppose that Santana is home, which is statement P, is false. Santana is at his desk, which is statement Q, is true. And that Santana is sleeping, which is statement R, is true. Is the compound statement true or false? When they say is the compound statement true or false, they mean this statement here that we have, that we're exploring. The entire statement, is it true or false? So basically they're asking us to look at a specific case. So let's figure out what case they're having us look at. Santana is home is false. When is P false? These cases here, 5 through 8. But Santana is at his desk, that statement Q is true. So when is P false but Q is true? Okay, case 5 and 6, right? 5 and 6. But now Santana is sleeping, that's statement R, is a true statement. So when is P false, Q true, but then R is true? That's here in case 5. So this is the case they're having us look at. That's the case where Santana is home is false, Santana is at his desk is true, and then Santana is sleeping is true. And they want to know, is this entire compound statement, is it true or false? What's the outcome? And the answer is, it's true. The compound statement is true. So once you have your truth table, Then you can look at whatever case you want, whatever scenario you want. That's kind of cool. Now, as we just saw, when we construct a truth table, we determine the truth values of a compound statement for every possible case. Like for this example, there's 8 possible cases. And so you and I are determining the truth value of every possible scenario. But if we want to determine the truth value of the compound statement for any specific case, when we know the truth values of the simple statements, then we don't need to develop. We don't have to develop the entire table. We don't need all of it. I think what's key though is that we have to know the truth values of the simple statements in advance, right? Then we don't need the entire table. For example, let's say we have this statement 2 plus 3 is 5, and then another statement, and let's say 1 plus 1 is 3. Okay, so let's say this statement here is P, and let's say this statement is Q. All right, now this is the thing. We already know P is a true statement, and we know that Q is a false statement. So when we write this statement, 2 plus 3 is equal to 5, and 1 plus 1 is equal to 3, that's the same thing as saying P and Q. Now, we already know that P is a true statement, that's for sure, and Q is a false statement. And so when you look at this, this is a conjunction. And you and I already know that conjunctions are only true when both of the statements are true. So therefore, we can conclude without constructing a big old truth table with all of the cases, we can conclude that this is a false statement. This statement up here is not a true statement because they're both not true. All right, check out this example. Determine the truth value of each simple statement. Then use these truth values, using these truth values, determine the truth value of the compound statement. All right, let's start with the first one. It says 1 million is greater than or equal to 1 billion. Okay, so there are 2 statements here because it's saying greater than or equal to. So basically, one statement can be 1 million is greater than 1 billion, and then the other statement can be 1 million is equal to 1 billion. You see there's 2 statements here, 2 simple statements. So the compound statement can be written like this: P or Q, right? Because 1 million is greater than 1 billion or equal to 1 billion. All right, cool. Now, what do we know about P? 1 million is greater than 1 billion? That's not true. That's a false statement. P is a false statement. What about Q? 1 million is equal to 1 billion. That's also false. So we have false or false. You know what I mean? Let me create some board space for us. There, I have a little bit more room to write. So we know that this is a disjunction. The only way a disjunction is true is if one of them is true. Neither are true. So then this is a false statement. And I don't need a big old truth table for this, right? Because I know the truth values of each of the simple statements. All right, let's check out the next statement here. Okay, so I need, there's 3 different statements here, all right? Montreal is in Canada is one statement. Beijing is in Mexico is a second statement. And then Santiago is not in Japan. We're actually going to say Santiago is in Japan for the third statement. So we need P, Q, and R maybe. All right, what we're going to do is we're going to translate the words into symbolic logic, all right? Montreal is in Canada, that's P. Or, right, you see the or right here. Beijing is in Mexico, so that's or Q. Now you do see the comma. You see the comma? So that means I'm going to put parentheses around this. And then you see the word but. That but is like the word and, right? It's one of our connectives, okay? And so it is a conjunction here. Santiago is not in Japan, so that means not are. So this is a statement, the compound statement for which we want to determine its truth value. All right. So if you need to Google some of this, that's fine. Montreal, you can do some research, but Montreal is in Canada. That's true. Beijing is in China. It's not in Mexico. So this statement Q is false. And Santiago is in Chile, not in Japan. So Q and R are false statements. So now what I can do is I can replace each of these statements with their truth value. So P stands for Montreal is in Canada. That's true. Or Q stands for Beijing is in Mexico. That's a false statement. And not R. So now be careful here. R is Santiago is in Japan. Santiago is in Japan is a false statement. So now just bring down the negation part. So not that false statement, not R, not that false statement. So be careful, not false, right? Which we all know to be true. So this is a disjunction, which means as long as one of these is true, the disjunction is true. So therefore, this is a true statement. And not false means true. So true and true means true. So the original statement, well, this statement here, the original statement, that entire statement, it's true. And we did not need a complete, comprehensive truth table for it.